Today let's discuss graph theory. A graph consists of a set of vertices and a set of edges that join pairs of vertices together. Graphs are generally represented with a capital letter such as G. Let's first explain vertices and edges and what they are. Each graph will contain what appears to be a series of dots. These dots are what you call your vertices. Each graph then looks like all dots are connected by straight lines. The straight lines are basically the edges. Now let us go over some basic graph definitions. A loop, for instance, is an edge that has the same vertex for both of its ends. In this graph, for example, we see that the edge lettered E begins and ends at the same vertice. This is a perfect example of a loop. Next, let us discuss a walk. A walk in a graph is a finite list of alternating vertices and connecting edges that begins and ends with a vertex. On this graph here, we will do what is called a walk of three, where we will trace over three edges, making note of which vertices are used along the way. The three edges in red are connected by vertices I, J, K, and L. Now let's take the same graph and add an additional edge between vertices I and L. Now doing a walk of 4, we have completed what is termed a cycle, which is a walk that starts and ends in the same place. Two other types of graphs are referred to as connected and disconnected. In a connected graph, there is at least one path connecting each pair of distinct vertices. A graph is disconnected if a pair of vertices exists so that there is no path between them. Here we have an example of a connected graph. Below, we see an example of a disconnected graph. Lastly, let us discuss what a Euler circuit is in a graph. A Euler circuit is a route which starts and ends at the same vertex and traces every edge exactly once without lifting your pencil or pen. In this graph, we have so far traced from E to C, C to B, B to A to D. We have now gone from D to E. This still leaves the edge between D and C to be traced. However, to get back to vertices C, we must retrace the edge between vertices E and C. This graph does not have a Euler circuit because of that. Now let us try tracing a Euler circuit with this graph. As you can see, we have completed going around this graph without having to retrace any edge. This graph does have a Euler circuit. And with that, this brings us to the end of this brief description about graphs. Thank you.